So let's talk about RAG, its use cases and some of the advanced topic on it, which includes chunking, indexing, re-ranking and query rewriting. A RAG, if you are not aware of it, it is an retrieval augmented generation method which reduces hallucination. The first step of the RAG is retrieval, which means in this case we store the information from the various source and extract the information. The information can be from anything like website, PDF, Excel and SQL, and we store the information that we extracted from the source for the later use. The storage is basically a database, commonly termed as vector-DB or vector store, which includes the files, ChromaDB and Pinecone. In this case, the files and ChromaDB are open source and can be used by everyone free of cost. But in case of the Pinecone, it is for the paid user only. So here is a drawback. This raw data from the text file, website or the PDF are unstructured and contains lot of noise. So if we pass this noise directly to the LLM without pre-processing, the LLM will not be able to answer our queries perfectly. Also, searching in our database will become very difficult as it will contain lot of the noise, and noise affect the search. This raw data can be very large. We know that the LLM has a fixed input length. That is, for the model like Llama, Mistral and GPT 3.5, they have around 4096 length of context length. So if we pass this data direct to the LLM without pre-processing, there is a high chance of information loss as LLM truncates the input larger than their context length. Now to solve this problem, what we do is chunking. The chunking is splitting the information into the multiple chunk. So if the information is there, then we split this information into the multiple chunk like chunk 1, chunk 2, chunk 3 and chunk 4. For example, the Ram is eating the rice, he is in London. Then this can be chunked into the Ram is eating the rice and now he is in London. So it has the drawbacks. So what is the problem with the chunking is that it breaks the information if not done correctly. For example, if we chunk the information by the character of 8, then the Ram is eating the rice, he is in London will be chunked as this. The chunked sentence doesn't make any sense for the model to give answer. So this is a main problem of the chunking. To counter this, if we do the chunking correctly, then the problem with the chunking will be gone, as there are multiple sources of the information that should be chunked. And for this, if the information that we are using is PDF, then we first split with respect to the heading tag like H1, H2 and so on. Now here we need to focus on that the split is not similar to the chunking. After we have chunked the information or after we have split our PDF into the heading tags, then what we should do is tokenize the chunking rather than character or word splitting. The tokenizer chunking used must be same as your embedding model. So if you are using an OpenAI embedding to store into the vector store, then ticktoken tokenizer or ticktoken should be used for the chunking. So in case of the website, we first convert our website into the markdown, as markdown are the source that can store the information better for a website. rather than sending our tag for the chunking. If we do the GET request for a website, it will include all the tag, and tags are nothing but a noise that increase the length of our input. So in the case of the website, we first convert into the markdown, split it into the same thing like h1 tag, and we do chunking. For example, in this case of the website, the more information are between the tags like this and this. So information that we need to answer the question for this should be in the between these two tags. So if we try to chunk this, then it is a better for our model to give answer. So now the step 2. Till now we have the information stored in our vector database after chunking. So after we get the information, what we do is cosine similarity. But why? The cosine similarity is done between the query and database information. The query is the question that the user asks, and database information is a place where we have stored our information from the chunking, or the PDF information or a website information that we have chunked and stored for the later use. So this is the problem same as Google search. Earlier, the algorithm like inverted index was used, which is keyword based searching. In this case, it is faster and cheaper rather than cosine similarity. But here is a problem with the keyword based searching. If a user asks the query as what language is Python, now Python is the reptile and also a programming language. So search might result into the reptile Python. So this was the major drawback that the keyword based searching holds. So that is why we use semantic searching in our case as well. So it is mostly preferred for the domain specific, and if you have the domain specific knowledge are only kept in your corpus, then the keyword based searching might be for you, because in your corpus the Python will be only either a programming language or the reptile. So the problem will be fast, or searching will be fast, and you can focus more on other thing. But if the corpus has a mixed information, this technique fails. So that is why we use semantic searching. The semantic searching is also done between the query and information on the database, which is vector DB or vector database. Now we have understand that for the searching we need query, and now query is what it determines what is or what should be extracted from the database. The what is now problem with a user query. For example, the query as I love dog but also I love cat. In fact, I want to know about snakes. Are you or are they animal? Give me the information about dolphin. The query given is very complex. Now if we pass this query to the database, then top result that we get from any kind of the animal will be dog, cat, snakes or dolphin. So result is not getting right information from the database, as our model should get the information from our RAG based application. So what is the solution to this? That is why we use query rewriting. Now I love dog and I love cats about the information should be changed to information about the dolphin. Now this will only give the information, or this will be stored in our database, and the more preferred and exact result will be extracted by using semantic search. So that will be solved by using query rewriting. Now what is an improvement? that can be done further to improve our query rewriting. Now first, we can remove each stop word from the query. We don't want this to make influence in our search while doing semantic search. So the third step of the topic, which is re-ranking. Now till now, we have seen how to store the information to our vector database and how to get the information from our database. After that is re-ranking. Now suppose you rewrite the query that get the good results. So after that, what we need to do is re-rank our result to get the top result from our sources. So only the fixed information or fixed input should be passed to our LLM, then giving the bunch of information that doesn't match with our query. So let's try building an application that reads the information from the website and answer the user question based on the website using all the topic that we have discussed earlier. The URL and the website that I want to get the information is of Fast API. So URL here includes all the pages from the Fast API website. So as discussed, for the step 1, we get the content from the source. Here, source is Fast API website. The information here is a raw HTML that we get while doing request.get from the URL, and which is all the pages that we have in the URL list. After that, we convert this HTML page into Markdown. The library that we are using here is HTML to text. So if we pass the raw HTML to this function, then it converts the HTML into Markdown. Now raw knowledge base includes all the information from the website in the Markdown format. As of now, we have the information from the source in the Markdown format. After that, we split the HTML with a header and subheadings, which is this. Now we define the Markdown separator like this. Then we chunk the splitted Markdown according to the tokenizer with a chunk size of 256. The chunk size or varies according to the embedding model that we are using. Here, the embedding model we are using is Sentence Transformer MS Macro Distilbot base v3. So if you are using the OpenAI embedding, then you should define the tokenizer name as TikToken. Then we embed the chunk Markdown and store it in the database. Here we are using files as a database. This can be done like files.from document, and doc process is all the chunked Markdown that we have splitted from the HTML, and embedding model is the Hugging Face embedding that we have discussed earlier, and so on. After that comes the query rewriting part. Here, if the user asks the question, what is the dependence used for a Fast API, then we refresh the question into the 5 different form, and each question is searched to our database to get the related answer that are closely related to the question refreshed. We store all the answer into our retrieve docs. Here in this case we have passed k is equals to 5. So 5 similar chunk will be fetched from the database for each question. So in total, for a 5 different refresh question, there will be 25 chunks that will be stored in the docs. Then we rank the 25 chunk according to the user query by the cross-encoder re-ranking function, which will give the score to the individual chunked through a query that the user have asked and re-ranks them according to it. After that, we pass one in the top 2 chunk to the LLM to generate the answer, which is shown here. Now this chunk or context 1 and context 2 are the Rerank chunk or the chunk which have the high score with the queries and which is high similar to the query that the user have asked. Then we pass that query to our LLM and generate the answer for this. I have prepared the Streamlit demo, so let's have a look. So this is a Streamlit demo. We need the URL from the Fast API, and if we just pass the URL into here, it will scrape all the website and the URL from the Fast API and store the information from the Fast API to our vector store. And so if you write the query as what are the dependency used in Fast API, then it first rewrites the questions into the 5 different things, get all the information from our vector stores and re-ranks the results and get one is our top 2 result from that. So in this case is answer as Fast API uses Sovereign and Unicon, which is true. Now let's ask, can you provide a boiler template for starting with Fast API? And here you go. Now this is the boiler template that it gets from the Fast API and along with the source it provides. So this is what I want to show you today. So at the last, if you want to do the same thing for the PDF, you need to first extract the information from the PDF. So there are 2 libraries that you can use. One is LMSEPA, which is quite good in extracting the information from the PDF, and other is PyMol PDF, which is also great tool for extracting the information from the PDF as a logic for extracting the text in the markdown format. So you can use these 2, and the code that I have shown earlier remains the same after the extractions, like splitting the text from the HTML or header tag